Now in this fifth class, let us solve some examples. See, our first example is calculate the change in entropy when 5 kg of water. You have to calculate what is ds. Mass is 5 kg of water. At 100 degrees centigrade is converted into steam at the same temperature. Given that latent heat of steam is equal to 2.7 into 10 raised to 6 joules per kg. Now you know that your change in entropy ds is equal to, it is dH, amount of heat absorbed or rejected, divided by T at constant temperature. So what is dH here? Amount of heat absorbed or rejected. Your dH is equal to mass into your latent heat. That means mass is 5 kg, latent heat is 2.7 into 10 raised to 6 joules per kg. Kg cancels, totally it is joules. 5 into 2.7. Your 5 into 2.7 will be of 13.6 into 10 raised to 6, so many joules. Then change in entropy. This is ds is equal to, this is 13.6 into 10 raised to 6 divided by, it is how much? 100 degrees centigrade means 373. It is 373, or this is 13, it is 0.0361 into 10 raised to 6 joules per Kelvin, or this is 3.6 into 10 raised to 4 joules per Kelvin. Then see the second one. Calculate the change in entropy when 10 grams of ice at 0 degree centigrade is converted into water at same temperature. Now similarly, this is second one. What mass is given is 10 grams. It is 10 into 10 raised to minus 3 kg. At 0 degree centigrade, T is 273 Kelvin. Converted into water at same temperature, given latent heat is, so your L is Here 3.36 latent heat of ice it is 10 raised to 5 joules per kg. Again here also you have to find out what is dH. dH is m into L. This is m is 10 into 10 raised to minus 3 kg. L is 3.36 into 10 raised to 5. This becomes 10 raised to 6 and it is 3.36 into 10 raised to 6. And the change in entropy ds is, you know that it is dH upon T. What is your dH? This is so many joules. dH is 3.36 into 10 raised to 6 divided by 37 and 10 grams. It is 273. And if you simplify this, you are going to get this as 12.3 joules per Kelvin. Now let us solve this third example. Follow this third examples carefully, because if you know how to solve the third example, you can solve any type of examples, particularly in this chapter. See, this third example is calculate the increase in entropy when 1 gram of ice at minus 10 degrees centigrade is converted into steam at 100 degrees centigrade. That means mass is given. Mass is equal to how much? 1 gram. This is equal to 1 into 10 raised to minus 3 kg. It is ice. Converted ice at minus 10 degrees centigrade. The initial temperature of the ice is minus 10 degrees centigrade. Is converted into steam at 100 degrees centigrade. So here totally 3 stages. One is ice at minus 10 degrees centigrade, and it has to first convert into water at 0 degree centigrade. Then after that it has to convert into steam at 100 degree centigrade. See, 1 gram of ice at minus 10 degree centigrade is converted into steam at 100 degree centigrade. Given that specific heat of ice is so much, latent heat of ice is this much, and latent heat of steam is 2.3 into 10 raised to 6 joules per kg. See, first let us calculate increase in entropy ds1. Temperature has been changed from this minus 10 degrees centigrade to 0 degree centigrade. Means this is T1, here is 263. Why it is 263? Because minus 10, 0 plus 273. And it is T2 is 273. Then from here to here, this becomes T1 is 273 and this T2 is 373. Now, first temperature changes from here to here. It is ice. Latent heat of ice is given 3.36 into 10 raised to 5. Now, this ds1 is equal to, so integration temperature changes from T1 to T2. This is dH upon T. dH upon T. Then what is dH? It may be mass into specific heat or mass into latent heat. When it changes from one temperature to another temperature, you have to consider the specific heat. When at the same temperature it is changing, you have to consider latent heat. Let us see how it is. Now it is from T1 to T2. This is equal to integration from T1 to T2. I will write this as mass into specific heat divided by T. Or this is here. M into S is taken outside. This is integration from T1 to T2 of 1 upon T. This we will going to get as, this is M into S into 2.303 into log of T2 minus T1. After simplification, you are going to get this formula. Now, your ds1 is equal to increase in entropy is M into S. Mass is 1 into 10 raised to minus 3 into S. Here you have to take specific heat of ice. Now specific heat of ice is given. It is 2.1 into 10 raised to 3. From here to here you have to consider specific heat of this ice. It is specific heat of ice is 2.1 into 10 raised to 3 into what, 2.303 log of T1 is, what is your T1? T2 is here 273 divided by 263. This 10 is to plus 3 minus 3 cancels. This is ds1 2.1 into 2.303 then into log of, if you divide this 273 by 263, you will going to get it as 1.0380, or this is 2.1 into 2.303. So log of this is 0.0162. Then if you simplify this, you are going to get it as 0.0783 joules per Kelvin. Now temperature is increased due to this change in the temperature. Sorry, change in the temperature. So change in the entropy is this much. Now at this constant temperature 273, entire ice is converted into water. Then you have to consider here latent heat of ice. Then in the second case, change in entropy, that is ds2, is equal to, since the temperature is constant, there are no two temperatures, dH upon T. So what is this dH? Now dH is not m into s, it is m into L now. This is m into L divided by, at same temperature it is 273. Then your m is once again 1 into 10 to minus 3 kg. L is the latent heat of ice. Latent heat of ice is 3.36 into 10 raised to 5, or this is upon 273. Then here it is 273. Then this becomes, see, 10 raised to plus 2, this becomes 336 divided by 273. That is equal to, it is ds2 1.2307 joules per Kelvin. This is what ds2. Now up to this you have calculated. Now from here to here, again temperature changes to convert it into steam. But you have to take the specific heat of water. So this change in the entropy, again you use this formula, m into s, it is what, d s3, it is m into s into 2.303 log of T2 by T1. Here T2 is 373 by 273. It is 373 by 273. Then what is S? So here to here water is present, water is converted. Specific heat of water. The CGS unit of specific heat of water is 1. SI unit is 4200, or in 4.2 into 10 raised to 3. You have to remember the specific. They may give or they may not give. This is, it is m is 1 into 10 raised to minus 3. S is, I told that 4.2 into 10 raised to 3 into 2.303 into log of 373 upon 273 is 1 point log of 1.366. Then, or this is 10 raised to minus 3 and this is plus 3. It is 4.2 into 2.303 into log of 1.366 is 0.1354. Then this will be your 1.3096 joules per Kelvin. Now, so due to this change in the temperature here to here, now at this temperature entire thing is converted into steam. Therefore, DS4 is equal to dH upon T. What is dH here? dH is m into L upon 373. What is m is 1 into 10 raised to minus 3. What is L? L is the latent heat of steam here. Latent heat of steam. Because here it is converted into steam. So 2.3 into 10 raised to 6. 2.3 into 10 raised to 6 divided by 373. So this is 2.3 upon 373 into 10 raised to 3. So if you simplify this, you will going to get this as 6.2 joules per Kelvin. Then total change in the entropy is sum of all these. Sum of all these means net increase in the entropy. It is ds is equal to ds1 plus ds2 plus ds3 plus ds4. If you add all these, you are going to get this as 8.8186 joules per Kelvin. Now in the fourth example, 50 grams of water at 0 degrees centigrade is mixed with an equal mass of water at 80 degrees centigrade. Assume that this is your 50 gram. At T1 is equal to 0 plus 273. It is 273. Let this 50 gram is A. Mixed with an equal mass of water, same mass of water Say this is B. It is also 50 grams. But what is its temperature? So T2 is 80 plus 273. This is 3, 15, 3153. This is temperature. They are mixed. Both of them are mixed. So this is A and this is B. Which gains the heat energy and which losses the heat energy? This is at 353 and this is at 273. This gains the heat energy and this loses the heat energy. That means your gain in heat energy is equal to loss in heat energy. Let your T be the common temperature after mixing. Then, so this is M into S, mass difference in temperature. It is T minus T1. That should be equal to M into S. It is T2. Because temperature decreases, T2 minus T. Then M is same both the side because same mass and specific heat also cancels. So T minus T1 is equal to T2 minus T. Then if you take this other side, it is 2T is equal to T2 plus T1. It is 2T is equal to T2 is 353, 273. This is 6, 2, 626 is 2T. Therefore, this common temperature T is 626 divided by 2. This is T is equal to 313 Kelvin. This is the common temperature. Now, with respect to this, there is an increase in the entropy and decrease in the entropy. So, when the temperature increases, this temperature increases. That is T2 T1 and this one is T2 T2. You know that increase in entropy it is ds1 is equal to integration from T to T1. It is dH upon T. It is M into S into 2.303 log of T upon T1. This is M is 50 into 10 raised to minus 3 kg. You know specific heat of water is 4.2 into 10 raised to 3, and this is log of T is your 313 divided by 273, or this is 10 raised to minus 3 and plus 3. It is 50 into 4.2 into log of, if you divide this, you are going to get it as 1.45, 1.1465. It is 1.1465, or this is 50 into 4.2 into log of this 1.1465 is 0.0593, and if you simplify this, you are going to get it as 28.67 joules per Kelvin. This is increase in entropy. Similarly, decrease in entropy. This is, you are going to get this as ds2 is equal to m into s, same thing, 2.303 into log of T2. It is T by T2. T by T2 is, T is your 313 divided by 353, and this is 50 into 10 raised to minus 3 into 4.2 into 10 raised to 3 into log of 0. Log of 8866 it is. Log of 0. No, 313 divided by 353 is 0.8866. 0.8866, or this cancels. It is 50 into 4.2 into log of this 0.8866 is minus 0.0522. If you simplify this, you are going to get is minus 25.24 joules per Kelvin. Therefore, net increase in entropy is 28.67 minus 25.24.